Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Akil from CDCS 266-1B. Today I would like to present to you Chapter 1, this is Permutation and Combination. So without wasting time, here we go. The first one is our learning target. Our learning target can be differentiate between permutation and combination. Next, we go to the next slide. Factorial. Factorial is n factorial equals to n minus 1, n minus 2, n times n minus 1 factorial. In permutation and combination also, we relate the rule of sum and the rule of product. What is the rule of sum? The rule of sum is if a first task can be performed in m ways, while second task can be performed in n ways, and the two tasks cannot be performed simultaneously, then performing either task can be accomplished in any other m plus n ways. The rule of product is if a procedure can be broken down into first and second stage, and if there are n possible outcome for the first stage, and if for each of these outcome there are n possible outcome for the second stage, then the total is designated m times n ways. We go to the permutation. Permutation is an arrangement of object in a particular way or order. The order is important, and permutation has two formula, which is when the question is repetition or without repetition. If repetition, we use n power r, and without repetition we use npr equals to n factorial divided by n minus r factorial. As we go to the example of permutation, the first one is with repetition. We read first the question: how many 4-digit codes can be created using the digit 09 if repetition is allowed? Which is in 0 until 9 we have 10 digits, and we have to arrange 4-digit codes. So we have 2 ways to answer the question. So the first one, you draw the line of 4-digit codes and use the number of digit that we have. So 10 times 10 times 10 times 10, we got 10,000 ways. Or we can use the formula is 10 power of 4 equals to same answer. Next, we go to the without repetition. We use the same question, but repetition is not allowed. So different here. After we use the digit 10, we use one of digit, we minus 1 to the next digit codes. So 9, 8, 7. So the answer is 5040 ways. Or we can use the formula NPR. So we just sub the value of n and r in the formula, and we got the same answer. So let's begin with the first question. 8 runners are competing in a race, and we need to find out how many ways the gold, silver and bronze medal can be awarded. This is a permutation problem since the order matter, so we just use the formula and sub the value of n and r, and we got 336 different ways to assign the medals. Next, moving on the second problem, how many distinct ways can we arrange the letter in geometry? Case 1, no restriction. So there are 8 letters, and since E repeats twice, the total number of arrangement is 8. So we just use the formula, and we got 20,160 ways. Case 2, both E must be together. So we treat the two E's as a single unit, reducing the arrangement to 7 groups. So the result, we just use the formula, and we got 5040 ways. Case 3, both E must not be together. So we just the total arrangement minus the arrangement where E is together, and we got the answer. Circle arrangement. The formula is n minus 1 factorial. Example question: in how many can 5 people can stand in a circle? So we just put the value of n, 5 minus 1 factorial, and we got the 24 ways. Next, we go to the combination. Combination is an arrangement of objects where the order in which the objects are selected does not matter, which is the order is not important. So the formula is NCR equals to n factorial divided by r factorial n minus r factorial. Or with repetition, n plus r minus 1 CR equals to n plus r minus 1 factorial divided by r factorial n minus 1 factorial. We go to the next example of combination. For the first one, with repetition, 20 basketball player for team of 5 players. Each player can play any position. How many teams of 5 can be formed? So the value of n is 20 and r equals to 5. So we just use the formula of combination with repetition, and we got 42,504 ways. The next one, without repetition, the same question but different formula. We use the formula of combination without repetition, and we got the answer is 50,504 ways. We go to the next question for combination. The question is, in how many ways can a committee of 5 form from 5 junior and 7 seniors? Case 1, there is no restriction, so we just put the value of n, which is 12, and r equals to 5 in the formula 12C5, and we got the answer is 792 ways. The second one is all committee must be senior, so this requires selecting all 5 members from 7 senior. So from junior 0, so 5C0 times 265, and we got the answer is 21 ways. And the case 3, at most 2 junior be the committee. This includes scenarios with 0, 1 or 2 juniors. So we calculate 5C0 times 7C5 plus 5C1 times 7C4 plus 5C2 times 7C3. So we got the answer 546 ways. I think that's all for me. Thank you. Assalamualaikum. Bye.